Hey everyone, this is Daniel for Rock the JVM, and this video is a discussion on Kotlin context receivers and how they can help us organize our code better. This tutorial assumes that you know some basic Kotlin, as always, and if you want to make the most out of this video, I recommend that you write code with me, and whenever you need to refresh your memory, just refer back to this video or to the written form at the blog with the link in the description, where you can also find the code snippets that I'm going to write in this video, more or less identical. So I'm not going to waste your time. I'm going to get straight to my IntelliJ project where I created some data classes specifically for the scenario that I'm going to demonstrate in this video. You can find this initial snippet in the blog post, so I recommend you pause the video and get the blog post handy and grab this code into your own IntelliJ project, as well as the build.gradle configuration file, which you can also find at the end of the blog post. So if you want, you can pause the video to grab these little code snippets and add them to your IntelliJ project if you want to follow along with this video, which I recommend you do to get the most value out of it. Okay, so this scenario assumes that you are working on a fictitious job board. We have a data class called job, which has some fields, a job ID, a company, a role, and a salary, all of which are value classes. So simple wrappers over essential types in Kotlin, and we have a fictitious job, so-called quote-unquote database, which I created as an in-memory map with a map of job IDs as keys to jobs as data structures. This is not really that important. You can create your own fictitious data here. Now, I'm going to demonstrate something that you are probably already familiar with, which is extension functions. So I will want, for example, to print all these jobs as a JSON into some sort of final data file that I can ingest into my big data pipeline or something like that. And I will create a function. I'm going to call this print as JSON with objects or jobs as a list of job. And this is going to be, let's say, jobs. I'm going to say join to string, and I'm going to have, let's say, separator equals comma, and then I'm going to have my prefix as the start of the array, postfix is the end of the array as a string, and the representation of every job inside is going to be something like it.toJSON. Now, the problem is that it2JSON doesn't exist because the job data type doesn't have the toJSON method inside. So I could create a function toJSON that returns a string, and I'm going to have a to do here, which would make the code compile, but because this job data structure is just a data class, I don't want to add too much functionality to it. So I would rather add the toJSON functionality as an extension method. So I would say something along the lines of fun job to JSON, and this would return a string, and I would return a, let's say, a triple quote string, and let me make the compiler work with me here. So I'm going to have something along the lines of a JSON object as ID colon, and I'm going to inject ID value. So we have the ID, then we have the company as $company, I think it's called name. Then we have the role, which is role name. And then we have the salary as salary value. Okay, so now that we have this job to JSON as an extension method, we can now use it automatically here inside where we want to print as JSON. This is great, but let's assume that we wanted to add the JSON functionality so that we can serialize not just jobs, but other data structures as well. In that case, we would have to add two JSON extension methods for all the data structures that we wanted to support. But the print as JSON, I would like to make it generic so that the whatever type that I have here has the toJSON method. So how would we write something along the lines of fun, let's say print as JSON generic, where we have things as a list of something. So I'm going to have a type argument here, fun a print as JSON generic things list a, and this return a string. But I would want this a type to be guaranteed to have this toJSON thing. So I would say something along the lines of the implementation of jobs to string, but instead of jobs, I have things. So things join to string separator and so on and so forth. But notice that we don't have the toJSON extension method on the A type because, of course, it's generic. So the compiler cannot make any sort of assumptions about it. But being the abstraction freaks that we are, we don't really want a specialized function that just works on jobs. We want a generic print as JSON function that works on any A type that may have the toJSON extension method on it. So how on earth do we write it? I just deleted the print as JSON on the list of job because I want to force myself to implement this sort of generic functionality. How would we do that? The way that we would do that would be to implement what is called a scope. And a scope is essentially an interface which has my desired function as an extension method. I'm going to give you an example of how that would work. So I'm going to have an interface. I'm going to call this JSON scope that will have a type argument A, and this would have not a method of its own, but rather it would define an extension method on the A type. So I'm going to have a fun A to JSON, and that would be a string. Now, with this definition in place, I'm going to introduce some concepts. When we add a job.toJSON, this job thing, so I'm going to add my little comment here so that you can notice my absolutely amazing ASCII art drawing. So the job data type, the job thing itself, is called the receiver of the toJSON extension method. The JSON scope, which has the a.toJSON, is called dispatcher, receiver. And the A type is still called a receiver. In our case, this little thing is called the receiver, or the extension function receiver. Which is to say that this JSON scope is a safe place to call the print as JSON function with, because in that quote-unquote scope, which is why we called it scope, the A type has a toJSON implementation. So it's up to us to implement the a.toJSON for a JSON scope of job in that case. So let me show you how we would change the signature of the print as JSON function. So given the fact that we have a type argument A, I'm going to add an extension function on the JSON scope. So I'm going to say JSON scope a print as JSON. So notice that in this case, when we added the print as JSON function as an extension method on the JSON scope, now we also have it.toJSON because the presence of the interface guarantees the presence of the toJSON extension function on A as well. All right, so the code compiles. Now, how would we make it work for a list of jobs? So ideally, we would like to say print line a list of jobs, which is my jobs database values, which is a collection job. Then I'm going to say toList, and then I would say print as JSON on this toList thing. So I'm going to have to wrap this thing around, and then I'm going to say print as JSON on jobs database values toList. The problem is that we don't have a JSON scope for the desired type. In our case, it's a JSON scope of job. So instead of creating the job.toJSON as a raw extension method on job, rather I'm going to create a JSON scope of my desired type. So I'm going to have a job JSON scope. And this is an object that extends JSON scope of type job. And then I'm going to override the extension method that I declared I would. So I'm going to have my override fun job.toJSON. So the functionality here has not really changed, but I created the job JSON scope, which guarantees the presence of the extension function of job. Now, in order for me to use the print as JSON, I would have to somehow use the job JSON scope in place because the compiler cannot really tell where to find it from. In Scala, we would do that through implicits, but in Kotlin, we don't have that mechanism, so we'd have to specify the scope explicitly with a with function. So I'm going to have with job JSON scope, and I'm going to use this print line print as JSON inside. So when I say with job JSON scope, notice that I have a JSON scope of type job, which I can use to call print as JSON. So I can say this dot print as JSON, which is the same thing, but this is implied. So the this keyword is automatically implied in this scope. Now this pattern is quite frequent in the Kotlin landscape. If you want an example, we discussed coroutines, where we also have a long-form video on how coroutines work, specifically launch async, which will take as argument a scope which grants them some extension methods. So this is an example of this pattern being used in the Kotlin standard libraries. But we have some limitations to this pattern. First of all, that the print as JSON is declared as an extension function on the JSON scope itself. So the print or the desired function is an extension of the scope itself, which is a problem because if we somehow have access to job JSON scope, we can also say job JSON scope dot print as JSON, which is really not necessarily what we want. We would like the presence of the print as JSON function so that we can use it directly, not necessarily on the object itself. The desired function being an extension of the scope itself also means that sometimes, which is the case here, I would argue, the desired function has no connection to the type itself. So because we have the print as JSON desired function as an extension of the JSON scope, the JSON scope itself has no place in our type hierarchy. So from an object-oriented perspective, we are essentially polluting our types with these, let's call this artificial constructs, so that we can have the desired structure when we actually use them. So we're going to overcome these shortly. And the third is that we're limited to one scope at any one time. Now, to overcome these limitations, we're going to introduce a new concept, which is called context receivers. This is the crux of the video that we are getting at right now. So Kotlin 1.6.20, if I remember correctly, introduced the context keyword, which allows us to essentially perform the same kind of functionality as we did earlier, but without the limitations that I'm outlining here. For example, if I wanted to add the print as JSON functionality given a JSON scope, the way that I would write it in Kotlin 1.6.20 in the later, my Gradle has 1.8 or something like that, I would add context, which is a new keyword. I would say context with JSON scope of type A. And I would say fun A print as JSON, not attached to the JSON scope itself. So I would enable the presence of the print as JSON function given a JSON scope A. This is a very subtle change, but it solves essentially the first two problems right off the bat, because notice that the structure is identical the way that we would use that. So this is a runnable application, and this would give us back the desired JSON array, which I really didn't test it before, but it should work. So the compiler is warming up and it will fire at some point. All right, so notice that we have our desired JSON array, and essentially, the desired function will not be an extension of the scope itself anymore. The desired function has no connection to the type itself, well, not anymore. So I cannot really call job JSON scope dot print as JSON. Notice that the print as JSON does not exist as an extension function of the JSON scope itself. So we're left with problem number 3, which is one scope at one time. This construct with context will allow us to pass multiple values here. So for example, if I wanted to add some sort of, let's say, logging functionality, I would have something along the lines of an interface. I'm going to call this logger. And I'm going to have a function called info, which has a message of type string, and this returns unit. And maybe I'd have an object called console logger, which I'm going to use as a scope itself. I'm going to have an object which extends logger, and I'm going to override the info function, and I'm going to simply print line message, and maybe with a tag or something like that. So I'm going to say info and the message that I'm going to pass as argument. So this val console logger is an object that extends logger, and the info method just prints something out. Now I'm going to use a context of type JSON scope and a context of type logger in my desired function. Now let me go organize my code a little bit, because I have my interface JSON scope A, and I have a value of type JSON scope of type job, which is what I need. Then I have my logger and my implementation of logger, and I'm going to place them right underneath. And if I have a scope, a JSON scope of A, and a logger, maybe I can print as JSON with some additional functionalities. So maybe I would do something along the lines of, I'm going to say info, so logger info, but I would have to pass an object of type logger. So I'm going to simply mention it here in the context declaration clause. So I'm going to say info, I'm going to say serializing, I'm going to have things as JSON. And I'm going to have return things joined to string and so on and so forth. Now, because my function is more than one expression, I'm going to cut the equals and I'm going to leave it at that. So notice that once I have the logger in scope or in place, I have access to the info method. If I cut this out, I don't have access to the info method. So the context essentially gives us the capability of adding new extension methods in the implementations that we want. So we have essentially eliminated problem number 3 because we can mention more than one scope at any one time. So the context clause can allow us to add multiple types, each with potentially its own extension methods. Now, the problem is that our main function doesn't compile anymore because we need to provide a JSON scope, which we already have, and a logger, which is what we are going to add next. So I'm going to say with JSON scope with logger, or console logger, the way that I called it. And now I have print as JSON because now that I have 2 of them in scope, I have access to the print as JSON function because the context detected them both. So naturally, first of all, the code compiles and it also runs by providing both functionalities. So the info serialization and the serialization to JSON, which is absolutely fantastic. So the first outcome of context receivers, and this is by far the most powerful, is the ability to grant some functionality to some types, but not others. In this case, we are granting the print as JSON functionality only for those types that have a JSON scope and a logger in place. Now, if you've watched my Scala content for a while, you may have noticed that I'm using this sort of phrasing to explain how type classes work in Scala. Type classes work in a completely different way, and they have a completely different organization of code in Scala, but we're essentially arriving at very similar outcomes, which is the ability to grant some functions or the presence of some functions only for those types that satisfy some requirements. The second very powerful outcome is a sort of implicit dependency injection, because the JSON scope and the loggers that are specified in the context clause are actually being rewritten by the Kotlin compiler to be passed as arguments to the print as JSON function. Now, I'm not going to dive too deep into how the Kotlin compiler works or how it rewrites function definitions, but look at the main usage of print as JSON. Notice that we pass the job JSON scope and the console logger just once, and here within we can have a very important piece of code that just uses the functions that are enabled within the scope. So the dependency injection was used just once for the cruft that we needed, and then for the business logic, the important bit, so this is the important bit, we are now free of the mental burden of passing JSON scopes and loggers and all that cruft that we needed to implement the logic that we wanted. The only slight downside on this implicit dependency injection mechanism is that it's very tempting and very easy to abuse. Let me give an example. So let's assume that we have an interface called jobs, and I'm going to have a function, let's say find by ID, where you have an ID which is a job ID, and this returns a job question mark, so a job that is nullable. You have an implementation of that, so I'm going to say class, let's say live jobs, which extends jobs, and I'm going to override the find by ID thing, and I'm going to, for example, log the fact that I'm searching, which means that I'm going to add a context to this class. By the way, context declarations can work for functions, for interfaces, and for classes as well. So I'm going to have a context with a logger in this case. So I'm going to simply call info on, let's say, searching for job ID. And then I'm going to return my jobs database applied to ID. And this is why I made the return value nullable here. So I have a service that essentially exposes some functionality, or let's call this a jobs repository, if you prefer that term. Now, let's assume that you have a different service that depends on this live jobs, or on this on an instance of the jobs interface. So I'm going to have a class. Let's call this jobs or job controller, which is something that you would write for exposing some HTTP logic. And let's say that this job controller returns a job at a certain ID already represented as a JSON. So you would have a context with a JSON scope of type job and then a logger. And I'm going to have a fun, let's call this JSON by ID, where you have an ID as a string, which is something that you would receive at an HTTP request, and then you would return a string, which is the JSON representation of the job with this particular ID. So notice that you would now have to use the sort of live jobs in this case. So I'm going to simply pass that as an argument to context. So I'm going to have jobs in the context declaration clause so that I have access to find by ID, for instance. So I'm going to say info, let's say searched or searching for ID to serialize. And we're going to have a val job ID as job ID with ID to long, because this thing is a long. The job ID is a value class where the value is long. So let me scroll back. So we have a job ID with long. Then I'm going to have return. I'm going to say find by ID with ID. So notice that I have access to the find by ID method due to the fact that I have jobs declared in my context. Then because this is nullable, I'm going to say question mark and then a let. And then I'm going to have an info, let's say job with ID found, and then return it to JSON, because it to JSON is available due to the fact that I have a JSON scope of job. And then I'm going to have an Elvis operator. I'm going to say no job found. Find by ID with job ID so that my code compiles. So notice that due to the fact that I have many types here declared in my context clause, I have access to all their methods. So if you want to disambiguate which method comes from which type, you can say this at logger, for instance, .info if you want to disambiguate. But that's not necessarily what I wanted to talk about. So this is kind of like a side note if you want to disambiguate which method comes from which type to read your code better. The problem that I wanted to emphasize is that this context clause makes it very tempting for us to pass many arguments here in the context clause just to inherit all our methods in this particular scope, which is sometimes not what we want. So for example, in this case, we have JSON scope and logger. These are kind of like craft types that will allow us some additional methods, but the jobs itself, the jobs instance, is a required dependency for the job controller to work, which should not be part of the context, but rather as an explicit argument to job controller. So what I would recommend as a good practice to pass your types that are responsible for business logic explicitly. So I'm going to have a jobs, and I'm going to make it a val so that I can use it here. So I'm going to say jobs find by ID, job ID, and so on and so forth. So the business logic should be passed explicitly, and what's unrelated to the business logic, so external or additional functionalities, for example, the ability to add, to serialize to JSON, the ability to log, and so on and so forth, abilities should be passed to context, and explicit dependencies or business logic should be passed explicitly. So let's say abilities should be passed to context, and business, let's say logic, should be passed explicitly. So there is a difference between, let's call this implicit dependency injection, just to grant yourself additional abilities. So this is another form of so-called inheritance, if you want to think of it that way. And the business logic, which is the actual DI, these arguments should be passed explicitly to your new classes. So there you have it, folks, an overview of Kotlin context receivers. I hope you enjoyed this video and found it valuable. If you liked this video, go ahead and click the like button for me and subscribe to the Rock the JVM channel for more videos like this. Check me out on Twitter and LinkedIn. I post fresh updates on upcoming material. And check out my Rock the JVM website. I have literally hundreds of hours of Scala and Kotlin and everything in between. I hope I see you there. And until next time, I'm Daniel, signing off.